All right, this lesson we're going to first review some things we've already learned that are in this chapter, as well as we're going to continue on and learn about how to find the distance between a line and a point that's not on that line. Okay, the first thing we're going to do is, for this warm-up on this diagram over here, we're going to go ahead and mark the congruent angles, assuming that line L is parallel to line M. So go ahead and put our parallel markings here. So looking here, we're going to be seeing, we want to look at all of our different congruent angles. Well, let's take a look at vertical angles. We're going to have here that angle 1 and angle 3 are vertical, therefore they're going to be congruent. And angles 2 and 4, putting a second arc on there, are going to be congruent because they are vertical. Before we move to the other intersection, let's go ahead and look at alternate interior, same side exterior, corresponding, all of these. We take a look, let's look at corresponding. Okay, it's the one that's most missed. Angle 1 and this intersection is on the top left. Angle 5 is on the top left. So these will be corresponding and congruent. And then we can go even one step further and say, hey, look, angle 7 is vertical to angle 5. So that one's also going to be the same measurement. And we take a look at angle 2. It corresponds with angle 6. Corresponding are congruent. So we'll put 2 arcs because it's going to be the same measurement. And then again, 6 and 8, we've got vertical congruent angles. On B, we are seeing here that we have the measure of angle 2. We're given some information, and the measure of angle 8. Okay, all we're doing is writing the equation. That's all we want. Okay, just write the equation. We're not going to solve, but we're going to write the equation for solving. If you look at angles 2 and 8, I've already, like on my students know, if you see my other videos, I draw a little car between the parallel lines. See, this is the road, so if we're interior or exterior. Angle 2 and 8 right here are going to be, look at our transversal, alternate sides of the transversal, and they're exterior to the road. So here we have alternate exterior angles, AEA for short. If you don't know that that is alternate exterior, write it out, or you can write this. You don't need to write both. Whichever one you're going to remember is alternate exterior. And we learned that alternate exterior angles are congruent, plus we have the congruent markings. So that means the measure of angle 2, two things are congruent, their measurements are equal, telling us we set them equal to each other. Measure of angle 2 is equal to the measure of angle 8, so we just take our algebra and we set them equal to each other. 3x minus 57 equal to 10 minus 4x. And that's all we're doing. Letter B. C, we've got the measurement of angle 3. And we've got the measurement of angle 6. If we look at angles 3 and 6, okay, 3 has 1 arc, congruency arc. 6 has 2 congruency arcs, meaning they're not congruent, and the only other option is going to be the supplementary with parallel lines and transversal, but let's go ahead and identify what kind of angles we have. With angles 3 and 6, we are on the same side of the transversal, so we're going to have same side, which I use as SS. So they're on the same side of that transversal, and we're going to notice that they are interior to the road, both of them. So we have same side interior angles. And we've learned that same side are supplementary. So what that means is the measure of angle 3 plus the measure of angle 6 will equal 180 degrees. Measure of angle 3 was 3x minus 57. We're going to add the measure of angle 6, which was 10 minus 4x, all equal to 180. Again, we're only writing an equation. They use the same algebra, but now we have a supplementary one. So this is our answer for this. Next, we're going to go ahead and write an equation. The equation of this line we do want in slope-intercept form. We're going to see here that they gave us the slope, m, and they gave us the y-intercept, b. So all we need to do in slope-intercept form, y equals mx plus b, plug in and move on. So we have y equals your slope, which was 5 over 6, 5 over 6x, and then we have plus b, so we have plus 9. Done and done, and we move on. We're going to write an equation of a line that is perpendicular to y equals 8x minus 2 and passes through the point 8, 4. We're going to graph both lines on the coordinate plane. I'm going to start off with going ahead and graphing y equals 8x minus 2. Remember, we need to start with the y-intercept at negative 2, and that slope, the rise over run, we have 8 over 1. It is positive, so that means up 8 and to the right 1. So go ahead and apply your rise 8, and then run 1. So we go 1, 2, 3, 4, 5, 6, 7, 8, and then run 1, and then we plot that point. We'll then take a straight edge ruler, something to trace, so we can get our line right here. And now we'll take a look at the perpendicular. With the perpendicular, make sure that we have highlighted perpendicular. Remember that your perpendicular is what I call the OPP recip, opposite reciprocal. My classes know that we have a little game show. This means change the sign and flip that fraction. So we're going to take our slope of 8. Remember, this is 8 over 1. And then if you've watched my videos, you've seen, I'm not sure if all teachers do it, but this means perpendicular slope. The M for slope, and then the subscript of that perpendicular sign. We're going to change positive to negative, and we're going to take that 8 over 1, and we're going to flip it to 1 over 8. So then we want to make sure that we're going through the points 8, 4. So I'm going to label this x1, y1. I'm going to go ahead and I'm going to come up with my equation in slope-intercept form using these points. And to do that, we need to make sure that we're using the point slope and then converting, practicing this. You can also use the solving for b if you'd like to. We'll plug in y minus 4, that's our y1, equals, okay, we want the perpendicular slope now. We're done with the 8, slope of 8, we're done with that. We've got it graphed and everything. So we want negative 1, 8. In parentheses, we have x minus the x coordinate, x1 was 8. When we go through and convert, the first thing that we need to do is go ahead and distribute. We're going to bring down y minus 4. Negative 1, 8 times x, just negative 1, 8 x. And then negative 1, 8 times negative 8 is going to turn to a positive, and it ends up just being a 1. Now we need to move that 4 over. Okay, we need y by itself. To do that, we need to add 4, making sure that we're adding the 4 on the right side, we're adding it to the 1. And we end up with y equals negative 1, 8 x plus 5. All right, let's go ahead and find the y-intercept at positive 5. Let's go up to positive 5 on your y-axis. And now with that slope, we have negative 1 over 8, meaning we're going to go down 1 and to the right 8. So from here, go down 1 over 1, 2, 3, 4, 5, 6, 7, 8. Go ahead and draw in that line. We'll trace it. And then at that intersection, it will end up being perpendicular. Okay. All right, so that's just kind of reviewing stuff. It's the first time we've seen the graphing a line and the perpendicular line. Let's go ahead and look at the distances thing that the title's about. It is universally accepted that when you say distance to, we're talking about the short. We're just going to assume we're looking for the shortest distance. Okay. When we have the distance between a line and a point that's not on that line, okay, make sure we're seeing a point not on that line, is going to be the perpendicular distance between them. Okay, so that kind of goes with what we just did on letter E over here in the warm-up. seeing that perpendicular distance. Now, we're not going to be doing a line necessarily, not with these first two. We're going to go ahead and take a look. We've got find the distance between the point -2, 7 and the line y equals 2x plus 1. The first thing we need to do is graph 2x plus 1. Positive 1 on the y-intercept. That slope of 2 means rise 2, run 1. So rise 2, run 1. I'm going to go ahead and get several points on here. Okay. Remember, also check out the opposite direction. Okay. Go to the left of that y-intercept. Instead of up and to the right, we're going to go down and to the left. Down to left 1. Practice getting those on there. And we need to understand how to apply the slope in both to the left and the right. Let's go ahead and trace this line. Pause at any time we need to get caught up, please. Now we're going to plot the point -2, 7. And we want to find this perpendicular distance. Now, what we need to do first is we need to understand the slope. The slope of our original line was 2. We want, first, let's go find the perpendicular slope. We need to change the sign and flip that fraction. Positive to negative. The 2 over 1 becomes a 1 over 2. So from this point, -2, 7, let's go ahead and we're going to use that slope until we get to the original 2x plus 1 line. So we're going to go down 1 over 2, down 1 over 2, and we're going to wind up right here. What we need to do now is we're going to use Pythagorean theorem. Okay? We're going to use your vertical and your horizontal distances to figure out what that distance is. Because remember, on a graph, you cannot count diagonally. So finding A and B, the two legs of this right triangle, we're going to see that the vertical distance is 2. The horizontal distance is going to wind up being 4, counting 1, 2, 3, 4. So with Pythagorean theorem, a squared plus b squared, etc. Plug in 2 and 4 for a and b. So 2 squared plus 4 squared equals c squared. And take your 3 steps. Square the numbers, in this case add them, and then square root them. We're going to do both the radical form, the square root form, as well as round to the nearest tenth. So here we'll have 4 plus 16 equals c squared. Then we'll have 20 equals c squared. And then square root as that last step. We will either have the square root of 20 in radical form, or if we round this to the nearest tenth, we will wind up with 4.5. All right, for the next problem, I encourage you, it says you try, I encourage you to pause the video and go ahead and try this on your own. We're doing the exact same thing, okay? First things first, let's go ahead and graph the original y equals -1/3 x minus 1, y-intercept at -1. And we're going to apply our slope of -1/3. This -1/3 tells us we're going to go down 1 and to the right 3. So down 1, right 3. Go ahead and get a few of those on there. Again, please go to the left of this point as well. So instead of down 1, right 3, we're going to go up and to the left. At least get one of those points on there, please. Let's go ahead and trace it. And then let's move forward and plot the point 2, 5. The slope of the original line that we have here is -1/3. So we need to figure out what the perpendicular slope is so that we can go ahead and apply it and figure out where our right triangle is. So again, we're going to change the sign and flip that fraction. Negative is going to go to positive, and we're going to take the 1/3 and flip it to 3/1, which will help us with our rise over run. Remembering that 3/1 is not accepted as the slope in an equation if we were to write the equation. So when you remember, it's actually going to be 3. So if we go from the point, like we did last time, the last one, okay, we're going to have to work backwards and go to the left, but there's nothing wrong with that, okay? We don't know exactly where it's going to hit that line just yet. So instead of going up 3, up 3, right 1, we're going to go down 3, left 1. So there's another reason I need you guys practicing going to the left of the point. So we're going to go down 3, left 1, down 3, left 1, and we're going to find ourselves meeting up right here. So this is the distance, and I'm tracing the lines a little bit different order here, but this is the distance that we're looking for. Again, cannot count them. So we need to find our vertical and our horizontal distances here. Your vertical distance, 1, 2, 3, 4, 5, 6. Your horizontal distance, 1, 2. So let's go ahead and move to Pythagorean theorem. Plugging in 2 and 6 for the A and B. Go ahead and square, add, and then square root. We're going to do the same thing over here, leave it as radical and round to the nearest tenth. Please push pause and do this on your own. And we should have the square root of 40 or round to the nearest tenth, 6.3. All right, so we're going to have line L contains these 2 points. We're going to construct a line perpendicular. Okay, so there's that perpendicular through line to line L through point 17. Then we're going to find the distance between these 2 lines, or sorry, between the point and the line. I apologize. We're going to represent the answer as radical and round to the nearest tenth. Exactly what we've been doing. So first, we need to figure out what our slope is for the original line L. So doing that, we're going to go ahead and use our slope formula, y2 minus y1 over x2 minus x1. With our coordinates here, here's our x1, y1, x2, and y2. And we'll go ahead and plug in. We're going to wind up with y2 minus y1 is going to give you 4 minus 2 over 5 minus 1. If we want to do it step-by-step mental math, we'd wind up with 2 over 4, which will then go down to 1/2. Okay, so this is our original line. Let's go ahead and plot the 2 points, 1, 2, and 5, 4. And we should see that positive 1, positive 2, the positive 1 over 2. We should see this. Let's go ahead and get a couple points on there. We'll go ahead and trace our line. And then now we're at where we were up here. We can move through, find the slope, the perpendicular slope, and then do Pythagorean theorem. Our slope we found was 1/2. So the perpendicular slope, change the sign and flip that fraction. Positive to negative, when we flip it, it becomes 2 over 1, which we should know is 2. Plotting the point P at 1, 7, we're going to apply this -2 slope, which is going to be -2 over 1, so we will go down 2 to the right 1 until we get to line L. Let's go ahead and label this as line L as well. So down 2 to the right 1. Down 2 and to the right 1. And here's where we are going to intersect. So we want to find this distance. Find your vertical distance and your horizontal distance. Vertical, we have 4. Horizontal, we have 2. And yeah, I know we just did one with 4 and 2, but let's go ahead and make sure that we have our work on here. A squared plus b squared equals c squared. Plugging in 4 and 2 for a and b. Pause the video now. Finish solving, or like I said, it's on number 2, that first one anyway. giving us our final answer. So there's quite a bit of steps, but just look at each step, get everything onto the graph so we can figure out vertical and horizontal distances and just solve with our Pythagorean theorem. And that is it.